Hello, everybody. This is Gigi from Kauai Community College. In this problem, I will be going over integration by parts tricky number 4. Okay, this is trick number 4. Suppose you have the integral of secant cube of x dx. Well, as soon as I said secant, you should be thinking, ooh, secant square, right? Because you know the antiderivative of secant square, which then tells me I should split this into two parts, secant square multiplied by secant. So I then would be thinking integration by part. The derivative of u dv is equal to uv minus the integral of v du, right? That's the integration by part equation. So I am going to let u be something that I can take the derivative of, and then I'm gonna let dv be something that I can take the antiderivative of, and in this case I will let it be secant square x dx, because I know the integral of that would be tangent x. Nice. So that means my u is going to have to be secant x. So then du would be the derivative of secant is secant x tangent x dx. Okay. So then again we have here uv. Okay, let's go back to our problem here. We would say then the integral of secant cube of x dx would be equal to u times v. That would be secant x tangent x minus the integral of v du, and that would be secant x times tangent square x dx. Tangent times tangent is tangent square. Okay. Ooh, what do we see? By parts again, maybe. But no, we don't want to do that. We actually could do a little trig substitution, because what is tangent square? Well, we know that cosine square x plus sine square x equals 1, right? Do you remember how that goes? So from there, if you divide both sides by cosine square x, you would get 1 plus tangent square x is equal to secant square x. You did that in trigonometry. Therefore, tangent square x will equal to secant square x minus 1, right? And that is what I am going to substitute in for tangent square x. All right, so I'm going to go ahead and rewrite my problem. The integral of secant cube x dx is going to equal to secant x tangent x minus the integral of, when I replace this into for tangent square, I will have secant cube x. That's good, right? Because that's what I started with. So based on number 3, we kind of like that that trick right there. Minus the derivative of secant times 1 is secant x dx. Okay, now this one right here, we can split that into 2, right? So this becomes, we can say secant x tangent x minus the integral of secant cube x dx minus a negative, that would be plus the integral of secant x dx. Okay, and this is the integral of secant cube x dx. Well, that's kind of nice because, again, we notice that this is the same as this over here. So we're going to go ahead and add that to the other side. And we would have 2 integral of secant cube x dx is equal to secant x tangent x plus the integral of secant x dx. Now, if you remember from one of the basic integration tricks of what that derivative is right here, with that antiderivative here, then you can use it right away. Otherwise, let's take a look. Here's that trick again. If we have secant x, we are going to multiply by 1. And our 1 is going to be secant x plus tangent x. Secant x plus tangent x, right? So this will become here, we would say the integral of secant x is going to be the integral of, here we have secant square x plus secant x tangent x on the numerator. And then on the denominator, I'm going to go ahead and rewrite that as tangent x plus secant x dx right here. Okay, and as you can see, the numerator is the derivative of the denominator, right? And so if you do a little u substitution, this is the integral of 1 over u du. And that will just be ln of absolute value of u plus c, right? So if we go back to our problem, this green part right here is going to equal to, let's rewrite the rest of it first though, 2 integral of secant cube x dx is equal to secant x tangent x plus that antiderivative, that would be ln of absolute value of tangent x plus secant x, right? And then we are going to go ahead and divide by 2. Go ahead and divide by 2 to get rid of that. Divide by 2. And we don't forget the plus c. And that would be our final answer for the antiderivative of secant to the 3rd power dx. Nice. There are like 2-3 different tricks in this one tricky part, right? So that's why this is beautiful.